Okay. Autonomous vehicles. John Chappell said that if 90% of vehicles were autonomous, 21,700 lives would be saved annually, and there would be 4,220,000 fewer crashes each and every year. Therefore, avoiding human error and reducing traffic-related fatalities. The high level of traffic-related deaths take the lives of over 30,000 individuals each and every year. Human beings process information at different rates and aren't able to communicate with one another instantaneously while driving, therefore making crashes inevitable. In contrast, technology incorporated in autonomous vehicles allow for the process of information at a far superior rate and create efficient collaboration to avoid an error that would ultimately cause a traffic-related death. Helen Kennerly said that human factors account for more than 94% of fatal crashes, most of which are on 16 to 22 year of age individuals who were texting and driving. Today I will be discussing how and why AI will effectively combat the high level of traffic-related deaths each and every year. Automated braking alongside collision avoidance are two primary technologies that are leading the way for autonomous vehicles. With the use of radar, LiDAR, and camera-based technologies, the vehicle has the ability to look ahead and detect oncoming obstructions. Whenever an obstruction is detected, there are several actions that can be taken. Typically, there are several other systems that are linked together in order to process and assist in collision avoidance as well as collision assistance. While the vehicle is making note of the potential collision, the brakes are being primed in order to allow for a quicker braking process. On top of that, the seat belts are being primed so that passengers are secured during the abrupt stopping of their vehicles. Based on the speed, distance at which the vehicle or the obstacle was detected, these systems may be able to coordinate and completely avoid a collision. However, if the vehicle is traveling at an unsafe speed and collision is inevitable, these systems are able to slow the rate of speed, potentially turning a traffic-related fatality into a traffic-related injury. It is mentioned by Ellen Kennerly that almost 1 million crashes could have been prevented if forward collision warning with automated braking was included in vehicles. While preventing collision, these systems still have to account for human error, which is being combated through the use of V2V, vehicle-to-vehicle, and V2I, vehicle-to-infrastructure communications. More recent technologies, such as V2V and V2I communications, have been developed to push the idea of autonomous vehicles to the next level of development. These technologies do exactly as their name suggests. Currently, drivers aren't able to coordinate with one another or their surroundings without the lacking communication and differentiating actions causing potential for an accident to occur. V2V allows for wireless interaction between one vehicle and another, where they share information such as speed, location, and the direction in which they are headed. This technology allows a vehicle to send and receive messages up to 300 meters, and as they share this information, such as speed, location, and the direction in which they are headed, no matter the obscurity, terrain, weather, etc., V2V allows for the detection of potential collision threats. The vehicles that could use V2V are limitless, and pedestrians may eventually be able to leverage this technology to enhance their interaction with motorists. V2I is another wireless communication involving a vehicle and transportation infrastructure located on roadways. For example, David H., for example, had said that if a driver is speeding towards an intersection where the light is about to turn red, the light may remain red in order to prevent other cars from colliding at that intersection. This technology allows for the complete communication between vehicles and traffic signals, crosswalks, and many other infrastructure on roadways, allowing drivers to be alerted of potential hazards and giving them the opportunity to avoid crashes. As mentioned in The Future of Cars by David H., such connected vehicle technology would address about 80% of crash scenarios that involve non-impaired drivers, which could help prevent the majority of these types of crashes that typically occur at intersections while changing lanes. While assisting in the prevention of these collisions, these systems will allow for human operation, which is being combated through the implementation of decision engines operating a fully autonomous vehicle. Decision engines offer a direct path to the autonomous vehicle. Decision engines can be role-based, where roles are hard-coded, or engines can have deep learning neural networks built by using human drivers to train these vehicles. Michelle Selwood. Many decision engines today are role-based and operate using a system of steps. planning which direction or path to take is the first step taken. These systems use an algorithm to determine what might be the most efficient and safest course to take. Then the system uses its communication features to measure the probability or predict its actions to coincide with its surrounding vehicles and infrastructure. Lastly, the engine uses this information and the other steps taken to make avoidance decisions, what route to take in order to avoid a collision, as well as tons of other rule-based decisions that may occur while driving. Deep learning neural networks have the capability of logging a user's drive time and using it much like a normal teenage driver would. This technology learns through these experiences and then uses them to make rational decisions during their operation. The difference between a teenage driver and an autonomous vehicle, however, is that the vehicle can share its experiences and allow for each to adapt their systems. The introduction of autonomous vehicles possesses a solution because this will completely eliminate crashes caused by human choice, as they will never be intoxicated, fatigued, or distracted, said Michelle Selwood. Now, additionally, whether they are hard-coded, learning neural networks, decision engines that take the reaction out of the driver's hands, and they make educated decisions rather than one that may result in human error or poor decision making. So in conclusion, automated braking alongside collision avoidance, V2V, vehicle to vehicle, and V2I, vehicle to infrastructure communications, as well as decision engines that can be role-based or deep learning neural networks, have the ability to be implemented, and these technologies are key in combating the high level of traffic-related deaths each and every year. Autonomous vehicles. John Chappell said that if 90% of vehicles were autonomous, 21,700 lives would be saved annually, and there would be 4,220,000.
You lost your proper cleavage, I'm sorry. That one can't go. Oh, well, she was fucking
I felt it so.
Autonomous vehicles. John Chappell said that if 90% of the autonomous vehicles allow for the processing of information at a far superior rate and create efficient collaboration to avoid an error that would ultimately cause a traffic-related fatality.